So, good morning, everybody, or afternoon, everybody. I hope that you're doing well on this Monday. Let's go ahead and take a look at this. We will be taking a look at inverse trig functions today, but first, let's recap what we've been working on for this past week, and that is finding missing sides, okay? Because what we're going to be doing today is different enough where if we don't know how to find missing sides, it's going to make everything a little bit more confusing. So the first thing we're going to do is label the side. So across from the 90 is my hypotenuse. Across from my reference angle is my opposite. And then next to that is my adjacent. So always go ahead and label those first. So if I'm solving for x first, I like to cover up and act like the other side doesn't exist. And I'm even going to write down SOHCAHTOA right here. That's so important. So when I go to write this down, what I'm going to see here is from my reference angle, I want the hypotenuse and I know the opposite. So I'm looking for something that has opposite and hypotenuse. That's going to be my sine. So I'm going to, for my x, I'm going to write sine of 27 degrees, right? That's my reference angle, equals, the O comes first. So that means my opposite is on top and my hypotenuse is on the bottom. So once I get my trig function set up, I'm going to go ahead and solve for x, right? I don't want x on the bottom, so I'm going to get that away. I'm glad that you're here. I have x sine of 27 degrees equals 15. I don't want x. I don't want the sine of 27 over here, so I'm going to divide both sides by sine of 27 degrees like this. So I get x equals 15 divided by sine of 27 degrees. I get out my calculator and I say, okay, I'm going to have 15 divided by sine of 27 degrees. I get, now it said in the instructions to round to the nearest tenth. So the nearest tenth is that first decimal. So I'm going to look here and I'm going to look to the right. If it's not 5 or higher, I'm going to keep it at 33.0. Okay, so that's what we did there. And again, I'm going kind of quickly because I did give you guys 5 minutes to do this. If you have questions, please just go ahead and ask. Okay, so that's my x. To get my y, I'm going to act like my x isn't there, right? So I'm going to cover that up. And I'm going to take a look at the sides I'm looking at. So I'm looking at the opposite and adjacent. So what uses opposite and adjacent? Tangent does. So I'm going to have tangent of my reference angle equals what's on top? Opposite. So 15 over y. So that's my trig setup. We're rounding to the first decimal place, and 0 is a number. So we want to include so it says round to the tenths. So we need to include the tenths because 0 is a number, right? If we went to 33, then we'd be rounding to the nearest whole number, right? So that's why we're having 0. I hope that makes sense. Yep. So if I'm dividing by y, I'm going to multiply both sides by y here. So to get y off the bottom, so I get, now, one thing you can do to speed this up is you can be like, hey, I know I'm not going to want the tangent of 27 there, so just go ahead and do both steps at the same time. So I'm going to have y times 1, which is y, and then 15 over tangent of 27 degrees. It's okay if you guys see a pattern to go ahead and do 2 steps as one, as long as we're not doing a proof. Okay, so I got, what do we got here? 15 divided by tangent of 27 degrees. And so I'm going to look at the first decimal, right? That's the tenths place. I'm going to look to the right. It's not 5 or higher. So I'm going to have y is approximately 29.4. Okay. And those are the 2 sides for this first triangle. So again, if you guys have questions, go ahead and ask in the chat. I was able to answer a question already. So make sure if you guys have questions with either the setup or the solving that you let me know. Okay. For the second one, I'm going to start it just like I would the first one. I'm going to start across from the 90. I'm going to get the hypotenuse. Okay. I'm going to get the across from my reference angle is the opposite, and then the one that's left over is my adjacent. I have SOHCAHTOA already written down, so I don't need to write that down again. If I'm going for W, so I'm taking a look. W is the adjacent side and the hypotenuse side. So the adjacent and the hypotenuse, that's going to be cosine. So I'm going to write cosine of 33 degrees equals, now cosine, the adjacent goes on top, so W is going to be on top, and the hypotenuse is going to be on the bottom. So to solve this, the W is already on top. I just have to get it by itself. So I'm going to multiply by 7. So I get 7 cosine of 33 degrees equals W. There's my exact answer. So in my calculator, I'm going to go 7 cosine of 33 degrees. And I get, I'm going to round to the first decimal. So the first decimal is 8. If I go to the one next to it, it is 5 or higher. So I'm going to have W is approximately 5.9. Okay, so there's a case of the rounding. And again, I am kind of going through this quickly because I gave you guys a lot of time to do this. So if you have any questions, please let me know. Next, so I found W. I'm going to cover up W. Oops, I'm going to cover up the whole thing apparently. I'm going to cover up W so I see what's left. I want to get Z, and I have the hypotenuse. So that is opposite and hypotenuse. So opposite hypotenuse, I'm going to be using sine again. So sine of my reference angle equals, the opposite comes on top. So I'm going to have Z over 7. I'm going to multiply both sides by 7. Oops, I was going to use blue there. To get rid of the 7. So I get 7 times sine of 33 degrees equals Z. Let's type this into my calculator. I get 7 sine of 33, and the first decimal is an 8. I go to the right, it's not 5 or higher, so I get Z is approximately 3.8. Woo! There we go. That is a lot of trig, but this is, guys, what we've been working on for like all of last week, right? We worked on it Monday, Tuesday, Thursday, Friday. So hopefully we've had a lot of practice. We're going to be good to go. And I think what you're going to see, it's really going to help us out today when we start taking a look at angles, right? So we spent all of last week looking at sides. So today we're going to look at finding angles, finding missing angles. And guys, this is so exciting because finding sides is kind of limiting because you have to know an angle. And it's like, well, how would I know an angle in real life? Well, there's tools to do that. But more realistically, it's easier to measure a side length, and then you use trig to find the angle. And so this is going to open up all sorts of beautiful things that we can do in the world with trigonometry. Okay? With right triangle trigonometry, right? And then if we get into wave theory and stuff like that, then it's going to open up really cool stuff with waves. Oh, so exciting. Okay, so what are we talking about today? We're talking about 9.6, and we're talking about inverse trig functions, right? Trig is short for trigonometry, so functions, right? So inverse trig functions. So the first thing we're going to have to talk about is, what the heck does, what's an inverse, right? What is an inverse? So you guys already have a pretty good understanding of what an inverse is. You just might not have used the word inverse to describe what you were doing, okay? So an inverse now this is kind of like the Krefft street definition. It got really dark in my room. Hold on a second. There we go. The lighting's a lot better there. I was starting to look like I was in a dark room and kind of creepy. So what is an inverse? So an inverse, and again, this isn't like an official definition. This is like the Krefft. What is an inverse? It's an action that undoes another action. Okay, and the example that I think fits best for what we're going to be talking about is shoes. Okay, so when you when you want to go outside, we usually wear shoes. So what we do is we take our shoe and we put it on our foot. And you can think of your foot as literally as the input, right? Because you put your foot into the shoe, right? So when you're walking around, your foot is protected by this shoe. So if someone wanted to come tickle your feet, they're going to be like, oh man, I can't get to their feet. Now I know that's a little creepy example, but the whole point is that the shoe protects your foot. Now at the end of the day, when you go inside, you probably have a rule about not wearing shoes inside. So you would take off your shoe. So taking off your shoe is an inverse of putting on your shoe, right? Taking off your shoe undoes putting on your shoe. Okay, so think of that when you're thinking of inverse. It's just an action that undoes another action. It's kind of like canceling each other out. Okay, so let's take a look at math examples of this. Oh my gosh, I'm always adding E's to math. Mathematics, right? There's an E after. Okay. Examples. So let's take a look at math examples that we'll be taking a look here. So now we're going to be talking about inverse trig functions. So the first thing, you guys have actually been doing inverses for a while, and it started with algebra. Now they're not functions, but let's say I had x plus 2 equals 3, right? Now to move that 2, we would call it the opposite. We would say the opposite of plus 2 is minus 2, right? And then the minus 2's would go to 0, and I'd get x equals 1, okay? Now, that in itself isn't an inverse function, but it gets you the idea. Do you see how we undid something that was there? Okay, so now let's take a look at an actual math function that is an inverse. X squared equals 49. That is some number times itself equals 49. Well, the inverse function of squared is a square root, because a square root and a square cancel out. Just like putting on a shoe and taking off a shoe cancels out. And notice how this x was the input. It was inside the squared. And so I'm going to have x, right? And then equals, and then I have plus or minus 7. Okay, yo. Yo, yo, yo. Then you could be like a yo-yo, and then you can like start yo-ing. Okay, so this right now, so x squared and the square root of x are inverse functions. Okay. So x squared and square root of x are inverse functions, okay? They undo each other. So when we're trying to solve, right, when we're trying to solve here, we want to undo a function, we need an inverse function. So just like we would undo addition with subtraction, if we want to undo a function, we need an inverse function. So that's what an inverse is. I hope that helps out with understanding of what's going on there, okay? Does anybody have questions so far? Any questions, comments, or anything? Right? So again, it's like you have a shoe on, you're taking your shoe off, you're being left with your foot. You're being left with the input. Okay? So let's bring this back to trig. So what do inverses have to do with trig? Well, let's take a look at what we have currently, right? Let's take a look at SOHCAHTOA. We have sine of some angle equals the ratio of the opposite side over the hypotenuse, right? So there's one of our functions. And then we have cosine of theta equals adjacent over hypotenuse, right? There's another ratio, so cosine of an angle. And then we have tangent of an angle equals the ratio of opposite over adjacent. Okay, so we have sine, we have cosine, and we have tangent. Okay, now what they all have in common is that look at this angle. So this angle, it's not sine times theta. It's not cosine times theta. It's sine of theta. It's cosine of that, right? So it's kind of like how a shoe doesn't multiply your foot. So that would be kind of cool. Right? Your foot is inside the shoe, right? So that angle is inside of sine. Okay, so all the angles are inside the function. Okay, so they're all inside the function. They are all inside. So to solve this, we're going to be talking about solving for angles today, right? We want to find the angles. So to do that, we're going to have to undo sine, cosine, and tangent. We want to take off the shoe and get to the angle. Okay? And you might be asking yourself, why are you keeping an angle in a shoe? Well, that is a good question, but for a different day. Okay? So to solve for the angle, we need to, and I'm going to put this in quotes, take off, because, right, this is kind of street definitions going down here, the function. Okay, so to solve for the angle, we need to take off the function. Okay, we can't divide. This isn't sine times theta. It's sine of theta. We're in a shoe, right? To take off your shoe, you don't take the same, a copy of that shoe and put it underneath your shoe, and all of a sudden the two shoes go away. That would be weird, right? Okay, so we're gonna take it off. So what does this look like? Well, let's make a table of inverse trig functions. Okay. Oh, how about this? Inverse trig functions, and then I'm just going to do this. Undo trig functions. I thought I could cut some corners, but I'm not going to. Okay? So inverse trig functions, undo trig functions. Okay? So to take off the shoes, we're going to have to use inverse trig functions. Okay? So what we're going to do is we're going to make a little table, and we're going to compare trig functions to inverse trig functions. Okay, so we're going to make a table of trig functions to inverse trig functions. And you should be having fun because we're talking about functions, and fun, it's right there. Okay, so and every function is fun. And that's a true statement. So let's take a look. So if we have sine, right? Sine is a function. The inverse of sine is we write sine like this, and then above it, it looks like a -1, but I'm going to use the zoom in function on my paper here to zoom in on this, and it's not a negative. It's on the bottom. Now, it's not going to look like it's on the bottom on your calculators or in the book because the printing press that makes that symbol doesn't have this included in its programming because it's not used enough. So rather than wasting money and putting in a different symbol, they just use the negative. But technically it's that because it's super important, guys. This is not a -1. A -1, if you guys remember from Algebra 1, means we would flip it. But that's not what this is. In fact, there's something else that we call when we flip it, and that's called a reciprocal. Reciprocal is when it's flipped, and the reciprocal of sine is called cosecant. Oh my gosh, right? Whoa, slow down, pump the brakes, Kraft. Too much information. You're right, we don't need to know the reciprocals in this class. You'll learn that in Algebra 2. What we need to know, though, is that this right here means inverse sine. Okay, inverse sine. Now, the cool thing about this, it actually doesn't matter the way that you say it. You can say it inverse sine or sine inverse. Okay, so either way works. You can say inverse sine or sine inverse. Okay, and then for the for the other ones, so having this symbol is really nice because cosine now, we just go like this, and this is inverse cosine or cosine inverse. And then I'm putting these in quotes, right, because it's just one way of saying it. And then tangent would be tangent inverse like this, or inverse tangent. Okay, so you got sine inverse. You got cosine inverse. You got tangent inverse. Boom. Those are the inverses. Now, where do you find these on the calculator? Well, there's two different things that we're going to look for on a calculator. If you have a physical calculator, the inverse buttons are the same buttons as your trig buttons, right? So here I have sine, cosine, tangent. And then up here in a different color, I have sine inverse, cosine inverse, tangent inverse. And then to use these, you use the color first. So I notice these are green. So I hit the green button first. It usually is the second button. So something on the screen will tell you your second. And then you hit that button and then you get an inverse. If you are on Desmos, right? So Desmos Scientific Calculator. Here I'm going to add a new layer here, and I'm going to make this Desmos. So if we're on Desmos, and I'll show you guys here, I'll make it nice and big. Make it, there we go. Okay, so we get a little, and I'm going to make it bigger. There we go. So we get a little problem here because here I have sine, cosine, and tangent, but there's no inverse in sight. That's because we're on the main menu. So there's an ABC menu that gets you a keyboard, which you don't need if you have a keyboard, and then a function. If you go to function, now we have sine and sine inverse. We have cosine and cosine inverse, tangent and tangent inverse. Now, notice here again, look how they look like -1. It is absolutely not -1, okay? This is sine inverse, cosine inverse, tan inverse. Now, some of you guys might be like, gosh, if it's so complicated to do, why don't they just change the symbol? And the short answer is yes, they did. There is another way of writing this. Okay, good talk. Programmers use what's called arc, and you write arc sine, arc cosine, and arc tangent, and that also means inverse. But since we're not doing that, I'll let a future teacher work on that for you. But for those of you that are curious, they go like this. Arc sine. Okay. Anyways, let's move on and let's figure out how the heck are we going to use this. Okay? How are we going to use this? And we'll practice, and then we'll be done for the day. Okay? Does anybody have questions so far? So if you're reading online, arc sine is the same as sine to the negative thing, like here. So arc sine, right? Arc cosine, arc tangent. I wish that they would make calculators that said arc instead of that -1. It would be so much less confusing. I wish we would just make the switch. Programmers are smart. All right. No one has any questions? We're doing okay, guys? All right. Let's get it. So, what are we going to do? So, let's do some examples of using inverse trig functions. Right? So we want to get to the angles. So let me do this first one with you and show you what's going to happen here. Okay? So we're going to have tangent of angle A equals 0.75. Now there's a couple of things I really want to point out here. Okay? This number right here, that's your ratio That's the ratio of sides, right? The 0.75 is the ratio of sides. And this A here, that's your angle. Okay, so we have tangent of an angle equals a ratio of the sides. But what we want to do is we want to solve for angle A. Okay, we want to solve for angle A. So to do that right now, right, we want to get angle A by itself. But the problem is it's inside a shoe. The only way to get rid of the shoe is to do the inverse. We cannot just divide both sides by tangent. Okay, it wouldn't even make sense because you wouldn't have an input anymore. So to do this, we're going to do tangent inverse of both sides, right? We have to do the same thing to both sides. So I always put it to the left because it's a function. It's tangent inverse of this. It's tangent inverse of this. Now in the future here, I'm not going to write those parentheses, but that's why we write it to the left, not on the right side. It's tangent inverse of this. It's tangent inverse of this. Okay? So the tangent inverse and the tangent, they're going to cancel out, just like a squared or a square root would cancel out. So I'm left with angle A, my input, equals tangent inverse of 0.75. Okay, so get your calculator, whether it's Desmos or a physical calculator, and we're going to practice typing this in. So on Desmos, remember you're going to functions, and you're finding tangent inverse. If you're on a physical calculator, it's most likely the second button, and then the tangent button. Okay, make sure your screen shows what you're doing here. And then I'm going to type in 0.75 like this. And I hit enter. And if I'm rounding to the nearest tenth, I'm going to get that A equals, so the nearest tenth is 8. I look to the right and I see that it's 5 or higher, so I'm going to round this up. Now I have 36.9. Okay, and I'm going to stop here. If you write your answer like this, you are not getting full credit. So I just really want that to sink in. This is not a correct answer. Okay, and can anyone tell me why? This is an angle. And what unit should we be in right now? What unit is our calculator in? What unit do I need to add to this? Yes, you're absolutely right. This is in degrees. So this isn't 36.9, it's 36.9 degrees. Okay, and that's super important. That's how we're going to know if we're looking at angles or if we're looking at sides, right? An angle, we're in degrees for this, right? So it's 36.9 degrees. Your calculator won't tell you units, guys. Okay, so 36.9 degrees. Okay, are there any questions so far? Does anybody have questions about using their calculator? If you guys are still using Wolfram Alpha, you can just type in tangent inverse. Or if you're using Wolfram Alpha, I would type in arc. So just type in ARC tangent, ARCTAN, and you can do it if you're still using Wolfram Alpha. Okay, so no one is saying they have questions, so I'm going to go ahead and I'm going to have you guys try these next two on your own. Sine of B equals 0.87, and C, cosine of C equals 0.15. So I want you guys to solve both of these for angle B and angle C. I'm going to give you guys 2 minutos. There you go. Give those a try, guys. All right. So hopefully what I was hoping you guys would do. So for this first one, we want to get to angle B. So I would take sine inverse of both sides. The sine inverse and the sine cancel out. So I get angle B equals sine inverse of 0.87. So again, it doesn't matter what the ratio is, right? It always is the same process. So I'd have sine inverse of 0.87. So I'm going to round to the first decimal. The next one is 5 or higher. So I get angle B is approximately 60.5, and then you have to put the degree symbol up there. So 60.5 degrees. Again, if you guys don't have the degree symbol, it's not the right answer. Okay? To solve this next one, it's cosine of C. So I'm going to take cosine inverse of both sides. And I get C equals cosine inverse of 0.15. I do that in my calculator, and I get angle C is approximately 81.4 degrees. Okay. All right, so that's kind of our intro into what is going on here, right? So that's just an intro. So now that we kind of have this basic, like how do we use, what's an inverse, how do we use an inverse, now let's take a look at where we're taking this. And where we're taking this is how to solve completely a triangle. So let's take a look at that if no one has any questions. Okay, so that's what we're going to work on next, and that is solving triangles. Let's see if we can get a little space here, guys. All right, so we're going to be solving triangles. Okay, so how do we solve triangles? Well, solving triangles means we're going to find all missing parts. Okay, we're going to find all the missing parts. So I'm going to do one example with you, and hopefully we have time for you guys to try one on your own. Okay, so let's take a look at our first example of this. So let's say I have a triangle, and I'm going to label it as A, B, C, and then I'm going to have some given sides. So I'm going to have one side is 3, one side is 2, and the other side is little c. So I have big letters for the angles, small letters, lowercase letters for the sides. So as you can see in this picture, I have 2 angles I have to find, and I have one side. So when I say solve the triangle, that's just saying, hey, you have 3 things to do. Okay? So we're going to be doing SOHCAHTOA, and we're going to be looking for the measure of angle A, the measure of angle B, and the value of C. Okay? And if you guys have questions again, I want you to just hop in and ask at any time, okay? Anytime. So taking a look here, I'm going to find angle A first. So if I'm looking at A, right, that's this angle here. So to get an angle, I have to know 2 sides. I can't use C, side C, because I don't know it. So if I'm looking at angle A, I have the opposite side and the adjacent side. So opposite and adjacent, that's tangent. So I'm going to start by saying, hey, tangent of angle A equals opposite goes on top, adjacent comes on the bottom. Okay, so we're going to be, notice here how I wrote this is exactly how I would write to solve for sides. There's nothing new there, which is really exciting for us. Okay, but then to solve this, I'm going to say, okay, I want to get to the angle. So I'm going to take tangent inverse of both sides. So I get A equals tangent inverse of 3/2. And just like that, I take a look at my calculator. I go tangent inverse, and then you can even use the fraction button if you would like, of 3/2. I hit enter. I'm going to round to the nearest degree. So A equals 56.3 degrees. Okay, and then I can go ahead and write that up here, 56.3 degrees. Okay, and again, if you guys have a question at any point, please ask me. Okay, because if you guys don't ask a question, I'm just going to assume that you guys are getting this. Okay, so we found angle A. Now we're going to find angle B. So we're changing our reference angle, right? You got to be careful. So notice how I didn't label. I didn't label because when you change your reference angle, your opposite and your adjacent, they're going to switch, right? So now, if I'm at angle B, the side furthest away now is the 2. So 2 is my opposite. So I want to use the 2 and the 3. That's going to be opposite and adjacent for angle B. So I'm going to use tangent again. But this time, the 2 is on the top and the 3 is on the bottom because I switched reference angles. So how do I go ahead and solve this? Well, I'm going to take tangent inverse of both sides. The tangents go away on the left. I get angle B equals the tangent inverse of 2/3. So I'm basically doing, it's the same triangle, right? But now I'm doing, instead of the 3 on the top, it's the 2 on the top. Oop, that didn't look right. Oh my gosh, what did you do, Craft? Craft, do you even? Sometimes I don't know, guys. All right, so I get angle B. Sorry, it's in the light there. Angle B is 33 point. Now I'm going to look at the first decimal to the right. It's 5 or higher, so I'm going to round up to 7, and I have to put degrees on it, right? So I'm going to have 33.7 degrees. All right, again, no one has asked anything, so I'm assuming people are doing okay with this. You guys are like, crap, bring it. This is nothing. All right, so the last one here is I want to find side C. Now, I could, and I want you guys to know this, I could go ahead and use my angles, but the problem with my angles is I rounded both of them, right? So if I can find a way to not use my angles, that would be really great too. Well, if this is a right triangle, doesn't Pythagorean theorem work? And yeah, it sure does. I can just go 3 squared plus 2 squared equals my C squared. Hey, pretty neat, huh? So I'm going to square root both sides, right? The square root is an inverse. They cancel out. Now, normally we would do plus or minus, but I'm not going to do the minus because we're doing a distance, and the minus doesn't make sense there, right? The triangle's not going to owe me a side. 3 squared is 9. 4 squared is 4. 9 plus 4 is 13. So there's my exact answer. Those are all my answers. Notice how I don't put a degree with the square root of 13 because C is a side length, not a rotation, not in degrees. All right, we're running out of time. I do want you guys to practice just a little bit. So I want to see how far you guys can go here. I know we're running low on time, but I just want to see how far you guys can get. Okay, and then if you guys have any questions. So I got little g, little h, and 13 and 25 degrees. I want you to solve the triangle. And I'm going to give you guys, how much time can I give you guys? I'm going to give you guys 2.5 minutes. So just get as far as you can. I know you might not be able to finish all of it in that time. If you do, great. Just try to get as far as you can. Try solving for angle G. Try solving for little g. Get a couple of practice problems in. Let me know if you have questions. All right, I don't have a lot of time, so I'm going to go through this, and if you guys have questions, please let me know. So the first thing I noticed is, what do the angles in a triangle add up to? They add up to 180, right? Angle H plus angle J plus angle G, they're going to be 180 degrees. So if angle H is 25 degrees and J is 90 degrees, right? This isn't easy enough. We don't have to use trig at all. We can just subtract 25 and 90 degrees, and we can get angle G equals 65 degrees, right? So right there, boom, I know this is 65 degrees. Okay. To get the other sides, for G, I might do cosine. So I might do cosine of 25 degrees equals G over 13. I multiply by 13. I get 13 cosine of 25 degrees equals G. If I type that into a calculator, I get 13 cosine of 25 degrees. I get, it's approximately 11.8, right? And it's a side, so I don't put degrees. Okay, so this side is 11.8. And then for the H, right, I might do sine. So I might do sine of 25 degrees equals H over 13. I multiply by 13. I get 13 sine of 25 degrees equals H. And I get 13 sine of 25 degrees. I get, why are people leaving, guys? We shouldn't be leaving. We still have 4 minutes left in class. 0.5 equals H. Yeah. This is such a pet peeve of mine when people leave class. Okay. So do people have questions about this? And it really, your goal is, you really can go this fast with trig, right? So we want to be able to find things quickly. Again, class isn't over, guys. So I have a couple of announcements that you guys need to hear. Don't leave. Okay, so I have these three here. So this is solving the triangle. So when we come back tomorrow, we're going to be practicing this. Hey, another thing that's really important for people to hear, I do have seniors in here. Please remember, seniors, that you guys are going to be taking your final at a different time than the rest of the students. You're going to be taking a different final. So your final is going to be on the 8th. It's going to be the last day. If that day doesn't work for you, you need to let me know. But we're going to plan on having your final on June 8th. So that we can get that done for you and make sure you know if you're going to graduate or not. Okay, so that's going to be June 8th for seniors. That gives you more time I'm going to give you a review to do, and you're not going to be learning volume, so you're going to be missing the last little bit. Okay? All right, so with that said, if you guys have questions, please come see me in my office hours from 8:30 to 10. You guys can now pack up if you need to pack up and do that. All right? Bye, guys.